My presentation is on the holistic configuration management at Facebook, and my name is Jeffrey Fluer. Placing ourselves in the framework of Facebook, we understand that short development cycles for software are more common today, especially at a company like Facebook, and where thousands of configuration changes can be made each day. Frequent configuration changes, and with a little bit of human error, and then these guys can have potential outages, and that's a pretty big deal for these guys. These guys want to run 24/7. So the way they attempt to contain these errors is through what they call a holistic method, or in my industry, what we call as defense in depth. So they use many techniques, both commercial and homegrown within their own company, but this paper really covers their homegrown tools that they've developed to help them achieve this goal. The challenges in this paper are many, but the ones they mainly spell out are as follows. Sprawl. What sprawl is what they have is a very large system, and this system has a lot of different configurations with a lot of different requirements and use cases. The next challenge they discuss is configuration authoring and version control. So one of the main problems that any software development team will have is that human errors can be quite common, and then manual editing of their config files can be highly error prone. So how do you defend against these configuration errors? The question that they ask in this paper is how to provide maximum assurance in a timely fashion. Another challenge that can happen in a large company is configuration dependency. There might be many groups having their paws on different parts of these configs, such as security, development staff, or management of OS. And the last challenge that these guys really hearken to is scalable and reliable configuration distribution. Facebook is a very large company, global scale, and they really want these configs to not only go out to their entire network, but also do so reliably. So let's touch on some of their use cases. One of their main use cases that I think is really cool is they gate new features. And what that means is once they have a new config or a new feature, they can selectively enable that on certain releases globally. The next use case I think is also pretty cool is they can conduct experiments out on the field. So what they're capable of doing is they can turn on certain things live in certain parts of the field and actually perform these things and see how they perform in the wild. Another really cool use case is application level traffic control. They can use their configs to actually shape traffic in many ways. Topology setup and load balancing is yet another way they can adjust their systems real time, and what that does is allows them to adjust their data store called Tau in real time to meet the needs of their current situations. They can also provide monitoring alerts and remediation, and what this allows them to do is react to issues and detect issues real time through their configs. They use machine learning models for a lot of their ranking systems, and what this encompasses is very large data sizes often, and they have a really cool solution using a peer-to-peer hybrid scheme to deal with these very large files. And the last use case addressed in this paper is about controlling applications' internal behaviors. So there's a lot of knobs in their production system, and they're able to adjust these things in a rapid fashion to bring the coolness that is Facebook. So now let's talk turkey. So this is really talking about the solution that they proposed. Now this is not the entire Facebook configuration management system. This is just a portion of it. But this gives you a big flavor for how Facebook manages their configuration of their system in a reliable and efficient and safe manner. So the first thing that really deserves mention is this backbone called Configurator. Believe it or not, that is its real name. So what this is really a framework for them to first get the configurations into their system as code, treat them as code, store them in a Git database, do some testing both live and in a standalone mode in a progressive manner as well, and then to distribute that out to all their servers out in the wild. There's sidebars, which is a very little specific thing, and that provides a configuration API for their PHP products. There's package vessels, so that goes back to the very large files that we were talking about in the previous slide. This is their hybrid scheme for how they deal with the large files. There's Gatekeeper, which I think is a really cool thing. That's their gating system for their product rollouts, and we're going to talk a lot about that in a bit. But I think that's just a really neat thing to have. And there's mobile config. So this is the config manager for their mobile apps, and mobile apps just have their just own issues due to the fact that they're hard to sometimes update. They have a lot of different flavors, and generally speaking, the bandwidth on them is not always the best. So let's first talk about this whole idea of configurator. Again, this is the framework behind all the configuration management that's talked about in this paper. So really there's a three-piece construction behind configurator. Piece one is, what is the manner by which configuration is created? And there's a whole philosophy which they take on. We'll talk about in a bit. The piece two is, once you've created a configuration, how do you test and gain confidence in it? You just don't want to create a configuration and then boom, put it into the user's hands, because you can often have outages, bugs, just frustrated people, both inside the company and outside. And the third piece is, how do you, once you have this confident configuration, how do you deploy it reliably and in a scalable fashion? So let's go to the first piece of the configurator, and that is authoring. So the authors assume two things about authoring configurations. One, engineers generally prefer writing code to hand editing files. Okay, that may or may not be true. They actually test this and see how that bears out in their actual company. The second assumption is config programs are easier to maintain than raw configs. That probably seems very likely, but again, they do support that with live data. So what follows from these assumptions and their big philosophy for how they deal with the first piece of the configurator is treat all configurations as code. As programmers, we'd love to treat stuff as code as much as we can. So let's look at their authoring system. It has four big pieces. Up top, it has the config data schema, and that's in the Thrift language. There's some common code and job-specific code up top. Generally speaking, those are in Python. And then there's a validator for Thrift, again in Python. What that does is that looks at the Thrift schema and makes sure that certain values are respected and upheld inside the compiler. So all these four pieces of code go into a compiler, and then they output a JSON file. And then that JSON file at some point gets placed into a Git repository. By having this type of system, this allows for code reuse and allows them to only have to work on the pieces and parts that are specific to that task. Another benefit of this approach is this prevents errors. And by having that validator up top and then the reusable code, it is less likely that there's going to be errors entered in their system. So also noted by the paper, there's some alternatives to how they author papers. The key thing is that the previous page is not the only way that configurations get in their system. There are also acceptable ways. Some simple cases don't merit the complexity of Thrift. There's also UI systems that allow them for very simple tasks to do those simple configs. Again, there's that sitebars that I mentioned a bunch of slides ago. That provides a UI for updating sitebars PHP configs without actually having to write code as well. But the idea behind all of these and this flavor that they're trying to support is limit the hand edits and provide less human errors. So once they have an authored config, how do they prevent these errors from getting any further? So one would be foolish to expect that just by having a good authoring system that there couldn't be errors. There will be errors, but they take a holistic approach or a defense in depth approach, and that is through the use of validators. They do human code reviews, they do manual testing, automated testing, and this really cool testing method called the Canary. So let's talk about the error prevention process. So the first thing that happens is the developer makes a change to the configs. The next thing that happens is that config is tested on a set of servers in an automated way. The next step that happens is those tests are taken and reviewed, and then the code is also reviewed. And that automated testing is called the sandcastle testing, and that's fed into the code review. And then after that, a bit more complex testing called canary testing happens. And what that does is that is trying to test stuff both in an automated way and in a small sense in the wild, to try to give the config a little bit more of a acid test, and trying to look for bigger problems that may not happen on a basic automated test. And lastly, once the canary testing has happened, the code review has happened, the automated tests are happened, and everything looks hunky-dory, then the change goes to the landing strip, and the landing strip will then commit that change to the Git repository. So now let's talk about the distribution of these configs. So there's a bunch of requirements, and if anyone's taken distributed systems, they're used to these kind of requirements. But for a large internet-based company, they always want scalability, because they don't know how large they're going to be. Obviously, Facebook is a massive company, has a massive servers on many continents. They want reliability. They have a good reputation, and they've worked hard to have it, and they want to keep it. Availability is also very important. There's going to be outages. Outages happen. They're just a part of life, and they want a configuration distribution system that if a few systems go down, that they don't lose everything, and then have their users just go to a different social media. They want data consistency as well. So what that means is when they apply config changes, they want these things applied always in order, so that they don't take one config change, miss one, and then apply the next one. They want them applied in the exact sequence that they were submitted. So let's talk about their configuration distribution as a process. So it all starts at the Git repository. So once things are in the Git repository, hopefully they're in good shape at this point. So something called the Git Tailor watches the Git repository, and when there's a positive change in it, it then gets pulled out of that by the Git Tailor. And then now it's a push model at this point. So what the Git Tailor does, it will push these config changes to a Zeus ensemble. Zeus ensemble, it's basically like a zookeeper system. Has a leader and a whole bunch of followers, and if the leader dies, then a follower takes over and becomes the leader. But after this, then the leader then does the following. It will push the changes to cluster observers. So these cluster observers get changes pushed to them from the Zeus leader, and then what they in turn do is they push their changes to the production servers. So once the production servers get these config changes, they become configured, and then hopefully everything is all good. And the thing about it is these configs are stored on the local hard disk of the production servers. So were the observers to go down, or the Zeus ensemble or Git were to go down, things would keep going and would be available, and still running. So let's discuss a few loose ends. There's many pieces and parts of this whole configuration system, but a really cool thing they have, and I really like, is their peer-to-peer system. It's called Package Vessel, and what it does is it distributes configs of a very large size very efficiently. Because it's peer-to-peer, it's very scalable, and it can just push stuff through very well, and bypassing many stages of their distribution system. Another really cool thing about it is I think it uses a type of BitTorrent, so it's a pretty much well accepted and well understood peer-to-peer system. So their real big bottleneck in their distribution system comes down to Git. The repository gets quite big, obviously, since Facebook is a big operation. And right now, as the terms of in the time of the paper was written, there's a real issue with Git kind of gacking with the large size of their repository. So at this time, they were talking about separating Git into a bunch of different independent repositories as a way to getting, scalable again from the Git side. So let's go back to talking about this whole gating technology they have, and it's called Gatekeeper. A very clever innovation. I really think it's cool. I've never really seen anything like this before. They probably do exist in many fashions, but it's a new one on me. And they use a gating system logic. And what it does is it manages code rollouts through online config changes. So when they release a code, generally speaking, it's in development, it's in disabled mode. So those code paths aren't being run. So in the wild, they might be a little bit risky and they might not want to take a lot of chances. So again, they leave it disabled when it first comes out. And then what Gatekeeper does, it's got some cool logic that allows it to incrementally enable that code path online. And what it does is it can use things like randomization values, and based on the values of random value that it computes, it can then turn that code on. So if there are problems found, the new code is disabled quickly by using that config again, and it has really cool increment levels of activation. It can start with only people in the company. It can start with only engineers in the company. It can activate 1% of their users and consumers, 10% of the user consumers, up to 100% of their users and consumers. And what that does is that gives them a staged level of assurance to know that not only is this release working on a small scale, but progressively in larger scales if they run into scalability issues with any kind of code. They can cut it off quickly and know, approach that threshold rather modestly. The last service I'd like to discuss is mobile configuration. So mobile config allows Facebook to provide for the unique challenges presented by mobile devices for configuration management. Fortunately for mobile devices, there's a native context class that Facebook can use to retrieve these current configurations. But generally speaking, the clients on the mobile device side pull the server for configuration changes, and then the server side only sends configs that are changed and relevant to that client. It uses a kind of a hashing system rather than trying to send a lot of data because the bandwidth can be quite limited. And lastly, there's also a push method for emergency changes, and usually that is used to deal with bugs. Here is some of the performance results that the paper quotes. They here show a plot showing the number of configs plotted versus the days of creation of the config repository. And you can see that raw configs are completely outstripped by the compiled fix. So this kind of shows that assumption mentioned about 10 minutes back, that engineers really like to program configs rather than hand edit them. Shows that that's a true assumption. Here's another result quoted by the paper, and this shows that the raw configs are really usually on the smaller size of the files. You can see that this is a cumulative distribution function, and you can see clearly that the 50% line for the raw config is around 300 to 400 bytes of code, whereas for the compiled configs, this 50% line is around 1,000 bytes of code. So the compiled configs, generally speaking, are your larger configs. So also, this shows the commit throughput for their 3 different systems for configuration management. There's a configurator, and that's for their configurations. There's the 2 on the bottom, www and FB code, and that is both the front end and back end code for their services. You can see that the configurations are actually growing in trend, and where the back end and the front end code are pretty much stationary. So this plot here is a very interesting plot, and this shows the kind of the weakness of their current configurator system. And what this shows is the Git repository, as it gets larger and larger in the number of files in it, that it actually becomes a bit more of a bottleneck in the fact that there's probably contention with using it, and also there's just more data contained in it. So the latency goes up and throughput goes down as the number of files goes up. Lastly, this plot shows the performance of Gatekeeper. This is kind of an interesting plot. You can see that it's plotted days versus the check rate of their Gatekeeper system, and it handles a pretty cyclical process. As the morning hits, you can see that the Gatekeeper has a higher throughput, and that's because more stuff is getting pushed through the pipe, and then at the end of the day, things go down. But Gatekeeper seems to behave quite well over time in managing throughput, which is really cool. Again, I like Gatekeeper. I think that's a really cool thing where these guys are able to, in a scalable sense, limit the number of people that use some of their code and the activation of their code in a way that allows them to check it in an incremental fashion. So let's talk about the pros of the paper. Again, very good paper, just like every paper that we're going to be reading. Really amazing. This shows a very comprehensive system for preventing bugs from affecting their releases. Facebook is a bleeding edge organization. They really want to provide as much excitement for their users as they can, as fast as they can, to as many people as they can. And bugs are a big problem for them. And they really have to take a very again, as it says, comprehensive way of dealing with that and preventing that stuff from happening in the wild. Outages are just very expensive for these kind of companies, and they don't tolerate that. So they need to have a very strong system for dealing with that. Also, this allows for agile development. A company like Facebook can't deal with taking development in the month to year-long cycle range. Some companies can. Some companies that do safety software or space software or even operating systems, generally speaking, they have to develop stuff on the order of months and years. So kind of a side benefit for agile development, I think it gives engineers a sense of accomplishment. And I think what this paper does is it's trying to provide a framework where engineers can make a change and see that happen in the wild same day. Really, really cool ideas here. Last thing I think is really cool about what these guys do, this accounts for more than one development group taking part in a config. So more than one group really has an interest in any given configuration. There's security concerns, there's system concerns, there's content concerns. All that was wrapped up into each config. So their system of development allows all these different concerns to be melded in every time they develop something and send it out in the wild. The cons for these papers are kind of hard to get to because obviously these guys are real smart and they they really think this stuff through. But a few that I see is that this approach may not work for all business models. It requires a decent amount of support to manage this kind of complex system, and frankly, from the engineer standpoint, it takes some buy-in. It almost takes some leverage on the engineer not to want to do things their own way, and that's kind of sometimes a little tough because there can often be cowboys. The validator code is only good as a person writing it. Sometimes, yep. People want to just get stuff out quick and don't really put a lot of effort into their validator code. Could lead to shortcuts, and shortcuts could defeat the purpose of that kind of stuff. Using coding approach for configs prevents a limitation on who can make these changes. Sometimes you always don't want an engineer, don't want to pay for an engineer to make a config change. You can find someone, maybe you can pay them less, or maybe it's something where yeah, it's something that requires an artistic touch or something, things like that. So yeah, I mean, maybe coding configuration as coding. Maybe it's not always the best idea. So let's talk about, does this paper deliver on the claims it has? It's very detailed and comprehensive paradigm, and it delivers rapid and safe code to the users. So I think it's a good paper in that sense. It really shows a very streamlined way of doing stuff rapidly and safely. There are weaknesses to large scale organizations, and that is human mistakes, and these guys recognize that. Humans do make mistakes, and I think when you deal with the right assumptions, you get often good results with your engineering that tries to account for that. Obviously, there's some proof in the pudding. Facebook is used by probably everyone that's listening to this lecture, and yeah, it's very reliable and very usable. So obviously, they must be doing something like this correctly, otherwise someone would knock them off if they had a better system. So usually the proof is in the pudding. Now, how is this relevant to operating systems? Well, configuration management for computers is a huge industry. I know in my company, that's one of the biggest concerns we have at this point. Creating a system for updating OS for large organizations is a challenge that's under-recognized. There's a lot of tools for this. There's a lot of tools you can pay. There's a lot of free tools, but yeah, when it really comes down to it, do they really cover all their bases like this paper outlines? Often, I don't think so. And a comprehensive system for managing operating systems in a large organization is a task that needs further study and discipline. The paper talks about that. It says that this stuff is there's a lot of open research on it. People can make money. Hey, any of us can make money on this stuff. So let's, if our next job doesn't work out, hey, let's all get together and do this. Any questions? You can contact me at my email, and I'm an online student, so unfortunately I can't answer them real time, but if you do contact me, I will get back to you. Thank you very much. Bye-bye.